All right, it's day 94 of 100 days of ML. Let me just edit the. Okay, day 94. And what we're going to be doing today is essentially reading Jan LeCun's paper on deep learning. So I think this is just like an introduction paper, some sort of review by Jan LeCun and Jeffrey Hilton, two of like the big names in computer vision and deep learning in general. So it's about like a 6 page paper, probably giving an introduction to deep learning and what convolutional neural networks are and all of that stuff. So I'm gonna go ahead and get this on my iPad so I can properly take notes and mark it up. Right. Go ahead and start with the abstract. Okay, pretty solid abstract. Just talks about how what exactly the definition of deep learning is, and also talks about the impact that deep learning has had over on large data sets. Essentially, for inputs such as images, video, and speech, it has brought upon a lot of changes and breakthroughs. There's two different main sections where it talks about the convolution and the recurrent nets. The convolutions have been really popular in vision tasks for images and videos, where recurrent nets have been popular for sequential, where including text and speech. Am I going to stop at day 100 or still continue? That's a good question. What I think I'll do is not continue with 100 days of ML specifically. This challenge will be completed. However, I might start up a new challenge like reading papers and implementing them using TensorFlow, which is something that I'm considering deeply. Because I think the next step in learning ML and AI, or going into deep learning, is to be able to not only just read these papers, but be able to kind of abstract the concept that is introduced in the paper and be able to implement it and produce similar results. Especially if I want to go into engineering sort of things instead of research. Anyways, continuing with the study. Oops, I had myself muted. So the first paragraph is talking about the effect of machine learning on the world, especially in different sectors, social net, e-commerce websites such as recommendation systems, and also the vision systems in cameras and smartphones. So it's been used to identify objects in image, transcribe objects, match new items, posts, or products with users' interests, and all these different sectors. It's not just one area that machine learning has been impactful on. So the conventional machine learning techniques were very limited due to their mm, due to the way that they were processing the data, and also because of the fact that GPUs were um, not strong enough to actually process the data at the techniques that were involved. So for a long time, especially in the early 2000s and the 1990s, machine learning just became stagnant due to the fact that the hardware wasn't excelling at the rate that the algorithms were. So we had all of these algorithms, but no way to actually put them to use. Right. Next up, it's talking about representation learning. It's process of feeding in raw data and automatically discovering representations needed for detection or classification. So it's raw data, but I'm not sure if this raw data is annotated or cleaned up in any way. Deep learning methods are representation learning methods with multiple levels of representation obtained by composing simple but non-linear modules. Okay, so I guess they're describing deep learning as a method for abstracting raw inputs into different layers, and at each step of the layer going higher, you're learning something new about that input. So from the starting, you're learning something very like small, and then as you abstract to more levels, you're using a more complex function, which can essentially determine more complicated information that's embedded into the input. So it's given an example here with how convolution layers learn the abstract layers of the images. Jeez, it's too early in the morning to be talking like this. And the end of this paragraph just talks about more applications of deep learning in other fields, especially bio, being able to make progress there in NLP, speech recognition, and image recognition. It's driving the research in other domains as well, and not just computer science. And it's talking about supervised learning, where we take labeled data and we're able to modify weights to get a certain desired output of accuracy or whatever it is we're trying to optimize on. So to adjust weights, we compute the gradient vector, which indicates the error. Basically, it's a second derivative which would indicate the increase or decrease in error. And then by traveling in the negative direction, we're able to get to a closer minimum of where the output would be the lowest. So if we have a parabola for our gradient descent function to optimize on, what it would do is to get to the bottom of that parabola. If it's a positively faced parabola, it would get to the bottom, and that would be where the minimum error would be, indicating what weights would utilize the minimum, would give you the minimum error. Stochastic gradient descent. Okay, I'm going to stop over here and then continue with this tomorrow. Almost done with 100 days of ML. Day 94. Tomorrow will be day 95. I'll finish up the last few papers and maybe get started into reinforcement learning, generative learning. It's the only thing that I haven't really explored in this goal, in this challenge. So maybe get that started. But I want to continue reading this paper for now. The next one is convolutional as in backpropagation. Okay. That'll be it for today. Pretty short stream.